Okay, we're going to be doing our integral test here. We're in section 11.3. And now in order to find out if this converges or diverges, we do an integral test. With an integral test, you want to make sure that whatever you have inside here with your sequence, that it's decreasing. So your series is not going to be decreasing because your series, you're adding it. But you want to make sure that your sequence itself is decreasing with each term. And in our case, it certainly is decreasing because we have 1 over n cubed, and then we plug in 1 here, and we would get 1. Then our next term, we would have 1 over n cubed, but we're plugging in 2. So this denominator is going to be larger. It's going to be 2 cubed, so that's 8. And then that's going to be 3 cubed, so that's 1 over 27. And so it's definitely decreasing. It's definitely decreasing as you go onward. So that's one thing we want. We want it to be decreasing so we could do our integral test. And there's another thing you have to make sure is that it's never negative. So you want to make sure it's non-negative no matter what you plug in from 1 to infinity. And you want to make sure that it's always decreasing. So knowing that this does satisfy those two constraints, we can do our integral test. With our integral test, we just take the integral of this. And it's been a long time, but if you remember, and we're having the same inputs here from 1 to infinity. And if you remember, we had to do limit as t approaches infinity and replace that with a t. Because we can't directly work with infinity with our integrals. And then we actually take the integral, that would be n to the negative 2 over negative 2. And this is from t, from 1 to t, with our limit as t approaches infinity. This is running out of ink. Now we could split it into two different pieces. So on one piece we've got negative t to negative 2 over 2. And the other one, which we subtract, is the bottom one. So that's what we have. And we're taking limit as t approaches infinity of all of that. So with this situation here, we've got a negative exponent with that t. That means the t is down here. And we're plugging infinity, that's going to 0. This is going to 0. And so we're left with negative 1/2. We're left with negative 1/2. Because this is taken to the power of negative 2. That's like taking it in the denominator to the power of 1 squared, and that would just be 1 anyway. So we have negative 1/2. Negative 1/2. And so this does converge to that. That's what it converges to. That's the integral test. So you just take the integral and you find out what it actually converges to. So it converges to negative 1/2.